Let's return to our shopping bills. So one thing which it might be interesting to find out is which shop is the most popular for a given type of item, right? So we have this category which tells us
like food, for example.
Food, for example. So which shop sells most food?
It's more bills.
More bills, more items per bill, total number of items.
Total number of items.
Because some bills will be mixed, like you have household and you have...
Just count the number of items, yeah.
So we'll just count the number of food items.
Food items.
And across all the bills, we want to know which shop is doing best in terms of food, most popular for food.
Okay.
So we want to keep track of this number of items of food sold per shop.
Yeah.
So there are only three shops.
Three shops.
Right?
So 3 shops, Sun General and Big Bazaar, I think, right?
Yes.
Yeah, so those are 3 shops. So 3 variables. We start with 0, I guess, count. Okay,
yeah, so we are keeping a count of the total number of items. So initially we will keep 0.
0 for everything. And we are doing iteration over the cards.
Yes.
And each card will iterate over this list.
Correct. So in each card we have to go down the list.
You have to go down the list.
Wherever it is food, we have to add 1. So get a total for this card.
And then
depending on which shop it is, we have to update that one.
Okay, all right. So some procedure we have which basically is doing this count, presumably.
Yeah.
And then
so we give it a card and then it gives back the number of food items.
Okay, all right, understand. Yeah. So now that we know procedures, right?
Yes.
All right. So SV stores 1, 2, 3, 4, 5, 6, 7, 8 items.
Okay. So I update this 0 to 8.
This is another SV stores 1, 2, 3, 4, 5, 6.
Okay. So that becomes 14 now.
1, 2, 3 SV stores again.
Okay. 17.
Sun General 0. Huh?
Okay. So no change.
0.
No change.
So Sun General is not selling 0. Not selling
food at all. It looks like.
Yeah.
Here's 1. Okay.
One
item. So occasionally people buy food there.
Yeah, this looks like that. Yeah. SP stores 3. So SP stores seems to be only selling food, more or less. Yeah.
20.
Big Bazaar for the first time. 1, 2, 3, 4.
Okay. So Big Bazaar has 4 items of food.
Sun General has
1. Okay.
SP stores has 4.
Okay.
Big Bazaar has 1.
Okay.
Sun General
none.
Okay. SV stores has 1, 2, 3, 4.
Okay, so 28 now.
1, 2, 3.
31.
1.
Big Bazaar. So 6 for Big Bazaar.
SV stores 1, 2, 3, 4, 5, 6.
So now 37.
2.
39.
1, 2, 3, 4, 5.
44.
None in Sun General. So Sun General is stationary type. 1, 2, 3, 4, 5, 6 SV stores. 7 SV stores.
51.
1, 2, 3, 4, 5, 6, 7, 8.
58.
SV stores. Big Bazaar. 1, 2, 3, 4.
Okay.
Big Bazaar.
10.
1, 2, 3 SV stores.
61.
1, 2, 3, 4, 5.
Okay.
Sun General.
Sun General. So that's 7 now.
1, 2.
63.
Oh, it's a big bill for SV stores. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9.
72.
Big Bazaar, nothing. And Sun General, 2 foods.
9.
So
it's very clear that SV stores is by far the most popular for food, and Sun General and Big Bazaar are almost equal, 9 and 10.
9 and 10.
So here,
but when we are looking at it, it looked like if we had asked similarly some other category like
stationery for instance, then it would have been different. Yeah. So obviously these are different types of shops.
Different types of shops.
Yes.
Okay, so now we did this by shop.
Yeah.
So 3 shops. But suppose we wanted to do by customer. I want to find out food. Just take food.
Yeah.
Who is the customer who is buying the most amount of food? Suppose find that out.
So then we would have to have the same thing. We would have to keep one variable for every customer. Right?
But there are a lot of customers.
Yeah.
Right. So we have too many customers.
So it would be nice to not have to keep a separate variable for each customer, you say. Somehow collect them.
Because also we may keep adding customers, no? Shops, they don't, I mean, you don't add shops only infrequently.
Yeah, correct. So as we collect bills for these same 3 shops over a period of time, there will be more customers.
Many more customers will keep coming.
So number of shops will remain 3.
Yeah, exactly. It will keep fixed.
Yeah. So if you look over 1 year, we might have the same 3 shops, but
many more
hundreds of customers might come. And we don't want to keep creating new variables for each one.
So what do we do? I mean, is there a way to?
So I think what we need is some way of connecting a customer name. Finally, what we want to do is maintain a number for every customer, but we don't want to give that a new variable each time.
Yeah.
So we have to have a variable which has 2 parts in some sense. It has a name, and for each name it has a customer. So it has a kind of, it's like a table in a sense.
Table where the rows are the names.
Yeah. So the rows.
We can keep adding more rows.
Yeah, we can keep adding rows, right? So we would have a name here, right? And for that name we have a count.
And when I give you a name, we'll check whether it's there already in the
Yes, I'll check if it's already there, I will update the count.
If it's not there,
if it is not there, I will start a new count with the value that you give me. So every name which I have not seen before.
Only thing is that it will be convenient if I don't have to keep searching to find the name.
Yes.
The way directly to go and check whether the name is there in the table, otherwise.
Yeah, so let's assume that we can do that, right? So like an index, right? So we can call
what we had this bookmark thing,
right? Like this bookmark thing. So we'll call this whole thing, for instance, we give it a name like food.
You know, I mean,
food count, right?
Yeah, you know, I can think of something which basically this happens, right? It's a dictionary. If you look at the English words in the dictionary, right?
Yes. So if you have a word,
I can just go, because usually there will be a way of quickly getting to that word, right? If we quickly get to that word in the dictionary.
Right. So we have basically this whole thing, we can think of it like a dictionary.
So
the names we can always assume are in some particular convenient to find order. So I can easily find out.
You can quickly get to the word.
Yeah. And
without having to search.
Yeah. And then the word will tell me what is the associated value. And if the word is not there, I will insert the word in the right place so that I can proceed with that.
So this is a dictionary. It's a dictionary for food count.
Yes.
Okay. So we are, what do you want to do? So each time we'll go through these bills.
Yeah. And each time now we look at, earlier we were counting the food items and assigning it to the name of the shop. Instead we will now assign it to the person who is shopping.
And first you have to check whether it's in the dictionary or not.
If it is in the dictionary, we will add. If it is not in the dictionary, we will create a new entry.
New dictionary element.
Yeah.
Okay, let's do that.
Yeah. So this is the first one. So clearly there is
Rajesh.
Nobody before.
Nobody. So you are starting the dictionary, first element in the dictionary, and putting 2 in it.
Yeah. So I'll just draw a line to indicate this connection. So this is 2.
Okay, 2. Then there is Abhinav.
So again this is, so here we can read it off, but normally it will be a lot of things. So there has to be an efficient way of checking whether this name has already been seen or not. But now this is a new thing.
Typically the computer can do this, right? I mean, it can take a name and check whether it's in the list or not quickly, right?
Yes.
You should be able to do it without searching. So Abhinav has 0.
So this says we have actually seen a customer called Abhinav, but he hasn't bought any food.
Okay. Now this is Akshaya, who seems to have bought a lot of things. 1, 2, 3, 4, 5, 6, 7, 8, 9 food items.
Okay.
This Neeraja bought 2 food items.
Okay.
There is Suresh,
okay,
who bought 1, 2, 3, 4, 5 food items.
Okay.
And there is Akshaya again.
So now we'll quickly find out.
Akshaya you quickly found. You straight away went to Akshaya.
Yeah.
And there are 3 food items.
Okay. So that 9 becomes 12.
So useful, no? This thing, because without variables now, this is not a variable, right?
Yeah.
These are not
variables. I have one single, I believe that this is like a single table. And I am looking at the first column using the name, and then the second column I am updating.
Alright, okay. So Sudeep, 1, 2, 3, 4.
Okay.
Ahmed.
Okay.
1, 2, 3, 4, 5, 6, 7, 8.
Okay.
Again Ahmed.
Okay.
1, 2, 3, 4, 5, 6, 7.
Okay, so that becomes 15.
Then there is Ahmed again, but 0.
Okay.
No update. Srivatsan, new name. 1, 2, 3, 4, 5.
Okay.
Srivatsan, 5. Radha, you have not seen Radha before, right?
No.
1, 2, 3, 4, 5.
Okay.
Akhil,
Again new.
1, 2.
Okay.
Julia,
Okay.
1, 2, 3, 4, 5, 6.
Okay.
Advait,
Okay.
1. Vignesh, 1, 2, 3. Neeraja.
Neeraja we have seen before.
You seen before? Yeah, 1, 2, 3.
Neeraja is now 5. She was 2.
4 actually, sorry. 1, 2, 3, 4.
Okay, 6.
6. Vignesh,
Okay.
0. So now 3. Akshaya, you seen?
Yeah.
1.
So now the 13.
George, seen George?
George is new.
Okay.
So we will have to make some more space. So George.
4. 4 food items.
Okay.
Aparna,
Also new.
Aparna never seen?
No.
Okay. 1.
Okay.
Mohit,
Mohit is new.
4.
Okay.
Ahmed you should.
Yeah.
3.
Okay. So that was 18.
Srivatsan, also seen I think.
Yes.
1.
6.
Another Srivatsan.
Yes.
0.
Okay.
Advait, 0.
Advait. Okay.
Abhinav, 0.
Okay.
Srivatsan,
Yeah.
1, 2, 3, 4, 5, 6.
Okay.
Abhinav,
Okay.
is there?
Abhinav is right at the beginning. We saw
1,
an empty.
2, 3, 4, 5, 6, 7, 8.
Okay.
We are done.
Okay. So now we have this dictionary
We have a dictionary with all the names
of all the customers who appear in this list of bills.
And we have the count of
Yeah, and for
food
each
items.
of them we have the count of food items.
Food
So we
items.
have Rajesh has bought 2 totally, Abhinav has bought 8, Akshay has bought 13, Ahmed is I think the winner with 18. So then Akshay is the second with 13, Srivatsan is third with 12.
Now,
So-
some kind of obvious relationship one can draw. I can try and say that the people who are buying the most amount of food are likely to be buying it from the shop that sells the most amount of food.
Yes.
It seems intuitive.
Yes,
Should be, right?
should be. Right. So we'll have to see now.
How do I verify that?
We'll have to now
You have
ask.
this list. You have the list of all the people.
Yes, and we have the list previously that we.
You can sort this, maybe. Can you sort it? No?
Yeah, so we could sort it.
Sort
so
it
we could
by-
get it. So we could get 18 as the maximum,
Sort it by
then 13, and then 12. So we are sorting it by the total number of
total number of food items.
items. Okay. And then we want to see whether that person actually buys these food
We can
items
just write
from.
here the sorted number 1, 2, 3. I mean, we just 2, 4, 5.
Yeah. So let's do 1, 2.
Who's third? 3.
This is 3. After 12, I think the next is 8, 4, 4. And then I
Then
think
it's
next
6,
is
I think.
6. Yeah.
We will stop at that, yeah? We will stop.
So these are our.
This is 5 or 6? 6.
And that's also 6. Okay. This is also.
Okay, so we have got, this is enough. I think we'll take these 5.
Yeah.
What do you want to verify? We want to check that these 6 people,
Generally buy their. This is all food. Buy from the top ranked food shop, which is
this is
SB
SV stores.
Yes.
How do you do that?
So we will have to go through and find the bills for these guys and see which shops. So we have to do one iteration through this whole thing and see if every bill in which they have food. Because for instance, Abhinav had a bill in which he had no food. So that bill we don't care. We are only interested in the.
So instead of keeping the count, so which means that instead of keeping the count, if I had kept the bill numbers here,
Yes. Then you would have had that directly.
possible.
Yes.
Here I kept the count, but
Yes.
suppose I had kept the bill numbers,
Yes.
then what I could do is I could go down these bill numbers,
And just check which shop they correspond to.
which shop they correspond to. How do I find that out, which shop they correspond to? I have to keep the shop
Well,
from the bill
from
number.
the bill number, assuming that we can look up the bill number easily from the bill number, then we could always look up the shop and any other details if we want. Whereas now we don't have any idea where the bills came from, so we have to go back and look through all the bills again to make sure that.
So I have to take all the bills of Abhinav, right? So if I had kept all the bills for Abhinav separately, this would have been much easier for me.
Yeah.
So instead of just keeping the count, if the dictionary had kept a list of all the bills of Abhinav,
Yes.
maybe I can do many things with it.
Yes.
That's an interesting
correct, yes,
kind of a representation.
Yes. So you could have a name
instead of keeping just the count, because count has already digested that data, right?
So name, what we had now is a single number, which is the count. And instead what we are saying is that we will keep a name
and keep
then
the
we
bills.
will keep a list of bills. So we'll say,
let's just do it for Abhinav. I mean, maybe it's useful, right? I want to check Abhinav because is he the highest? Who's the highest? Akshay is highest.
Ahmed is the highest.
Okay, let's do Ahmed. Okay. Suppose I want to find out all the bills of Ahmed, right?
Yeah.
So I'm going through all the bills like this. So this is Ahmed.
Yeah.
So 29.
So this is now 29.
Right? Neeraja, Vignesh, Advait, Julia, Akhil, Radha, Srivatsan, Ahmed. Okay. This is one more. 25.
Okay.
18. Okay. Yeah. Akshaya, Suresh, Neeraja, Akshaya, Abhinav, Rajesh. Okay.
So these are the 3 bills of Ahmed.
I may have missed something. That's all right. It's all right. Are there 18 in that?
No, so there should be one more food bill because there's one bill where he didn't go to. Didn't buy any food at all. So I think there should be a 4th bill for Ahmed which has some food on it.
Here that is. Okay, all right.
So that's 20.
All right.
Right. So we have these bills, of which one of these bills.
So if we had, instead of counting, we had put these bill numbers there.
Yeah. Then we could say. Then we could say that bill number 20, for instance, we could just look up quickly and say that it is SV. And then
this is SV.
Then 18 is also SV.
18 is also SV. 25
is sun, but and sun is no food. Right? So it actually doesn't count for our hypothesis.
And 29
is SV.
Is also SV. So
on the 3 bills where he actually bought food, right,
they were all
from SV, which is what our hypothesis was. That
so at least for Ahmed that confirms.
Yes.
Now we have to do the same for Abhinav.
Akshaya, for example.
Akshaya we have to do.
Yeah.
But we can do that. And if we do that, then we should be able to confirm our hypothesis.
Yeah.
Right? So what we have seen basically is that when the number of, in the case of shops, number is small
and fixed, likely to be fixed, it's easy to keep track of one variable per shop.
One variable per shop. So it makes sense to keep it as a variable.
Yes.
But when the number is larger like this,
then we
also it's keeping on changing, it may increase also.
Yeah. Then instead of keeping separate variables for all of these and confusing ourselves, because we have so many variables in our thing, we can think of this whole thing as one variable.
One variable, one thing, one entity.
One entity, one structure which has a way of indexing through the name to a value.
And the value itself could be a list, as we saw
could be a list.
So initially we kept the count, but it was more useful basically to keep the list.
So this is a kind of dictionary, as we called it, where the index is Ahmed and the value is this list of shopping bill data, shopping bill numbers.
Indices, index into that.
Yeah.
Okay.